Welcome back. My name is Shayan Sengupta. I'm a partner on the investment team at Multicoin. And for the next 30 minutes, this is going to turn into an AI conference. So put away your ideas about consensus mechanisms. We're going to be talking about GPUs for a little while. But in all seriousness, I mean, it feels like, given OpenAI and the 20th seed stage startup that's announced funding this past week, it feels like there isn't enough silicon in the world to kind of service the demand that's coming into the sector. And I'm fortunate to be sitting next to two people who are going to solve that problem. So I'll quickly introduce Trevor Harries-Jones, board member of the Render Network Foundation and chief operating officer at Otoy, and Ahmad Shadid, founder and CEO at Antpit, or IONET, formerly known as Antpit. They just did a rebrand. I talk to Trevor and Ahmad multiple times a week. I haven't had the chance to do it in front of a live audience, but this should be fun. So I think we start with just table stakes. Trevor, what is Render? Let's start from the real basics. What does the network do? What's the history of it? And we'll go from there.
OK. Well, to date, the Render network has been focused on making movie-quality rendering fast and affordable. Motion graphics artists across the world contribute their idle compute to do render jobs in parallel. So we have thousands of distributed GPUs that perform render jobs in a fraction of the cost and time.
Great. And so super quickly, for those who aren't familiar, what is rendering? Like, what is that process? Why does it need GPUs? Tell us a little bit about it.
Yeah, so rendering is the conversion of a model, a computer model, into pixels. And you know, it was pretty abstract to me when I came on too. The real truth is it's everywhere. It's in movies, games, NFTs, videos, architecture, and more. The other important thing to understand about rendering is it takes a lot of compute. And it turns out the GPU is best suited to do that compute. And so a whole industry has really been formed on the back of that. And you know, when we look back the last 15 years, we've gone from grainy pictures to grainy videos to better and better videos. You know, we're at 4K videos right now. And we're actually on the cusp of a big change as the world starts transitioning to 3D. You know, Apple and Samsung are dipping their toe into the AR, VR world. And you know, for us, that's really exciting because that equates to about 100x compute need from a 4K video today.
Cool. Yeah, I've seen it described as like pixels, and so you know that's the most parallelizable operation that can exist, right? Like each individual pixel that shows up on a screen, it's clear that GPUs are useful for that, and multi-thread processors are kind of the standard. And so we can get into that in a little bit. But Ahmad, tell us a little bit about IONET. What is a network? Why did you start it? Give us the quick 2 minutes.
Yeah, thank you for having me here. I think mainly IONET is the deep end of AI. We see that looking at the future, definitely we see the AI taking part of, already it's taking over all our life, and maybe now we just notice it because of the ChatGPT. And I just see the shortage of supply, and there's just a real need for an IO or some kind of like the AI category in the coin market cap, tokenized models, GPUs used for in a deep end. And yeah, that's how I started IONET. As it consists of multiple elements, from IO Coin, IO Cloud, IO Ventures, IO workers, and IO suppliers, and so on. All of them work together to make this ecosystem of decentralized compute networks specifically made for enterprise AI use case, which is going to take over the AI and which is actually most of the AI volume currently.
Got it. So, I mean, we should start there, right? Like you mentioned the enterprise use cases. You know, NVIDIA beats earnings quarter after quarter. You keep hearing about how there's a massive chip shortage in the world. People are fighting over H100 capacity, A100s. Sort of the spot rental rates for each of these things seem to be like spiking upwards, like those gas price charts. From your experience talking to the demand side as you see it, in your case, rendering, studios, artists,
Yeah.
and Amal, in your case, kind of early machine learning teams. How accurate is that assessment of the world? Like how big is the shortage? Who needs chips, and how is that distribution of compute in the market today?
Yeah, go first. Yeah.
We're really in two different worlds. So to understand it, you first got to understand GPU production, which is really a volume pyramid. At the entry level, they have the most production, and on the flip side, at the high end, the least production. And their cost structure is the same. So, when you look at the top NVIDIA chip, the H100, I think it goes for $30,000 plus at the moment, if you can get your hands on one. And that's about 15 times the cost of the top-end general purpose 4090 card. So a staggering difference at the top end of that pyramid. And the crazy thing is that H100 isn't 15 times as performant for all jobs on the GPU. It's actually really customized for training large models. Think GPT chat. And it's true, there's a massive shortage in that area. However, just because it's really good at GPT chat doesn't mean it's good at all AI. At training different models, at inference, and very much so at rendering. We know from talking to partners that many of the diffusion models that you see out there were not trained on H100s, but on less performant models. And why that's important is those models are very close to the consumer models we see on the render network. So an easy lateral move there. I think the real stat that everyone needs to understand, or the picture you need to see, is actually the overall production. There are an estimated 5 million high-end enterprise GPUs in the hyperscalers. So 5 million on the one side, and then there are over 1.5 billion consumer GPUs out there. So 5 versus 1.5 billion. Just a staggering gap. Now, obviously, not all of those GPUs are suitable for AI and for rendering, but we estimated at least 20% are for rendering, and a large subset of that for AI. So there's a really massive opportunity that I don't think goes away with the current bottlenecks on production. And for me, what needs to happen is somebody needs to step in with simple workflows, orchestration, and an incentive model for both rendering and AI.
One more thing to add, I think, I divided in 3 layers. So the first layer is, if we talk about the supply, and then the models, because it's connected to the supply, and then we talk about the cost. So if we talk about the supply, the compute power requirement for AI apps is doubling every 3.5 months. Now, this study has been done from 2010 to 2020, not counting what happened after that. So it was already 3.5, it's doubling every 3.5 months. And that means 10 times every 18 months. So the amount of compute power we need for AI apps is just growing and growing and growing at massive compound annual growth rate. And then if you look at the more slow, it's just 2x every 18 months. So we're not able to keep up with the demand. And we have just scratched the surface of how much GPUs we need. The amount of to give you another example, how many more GPUs we need. On Hugging Face, this is the second layer of the models, because we need the GPU because we're going to run a model or train a model on the GPU. So on Hugging Face, it's a GitHub for GPUs. It's a GitHub for models. Engineers build a model, they store it there. Just the open source models on Hugging Face. Currently, there are like 360,000, 380,000 models. Now, just last week, there were 340,000 models. And then 1 week later, I'm been monitoring this in the last 3.5 months. We're adding around 20,000 models a week. That's a lot of models. Now, just like the App Store, I'm like saying we're adding 20,000 apps a week to the App Store. I'm not talking about how much compute power each model needs to run. So imagine how many models, at this growth rate, how many models will be in 10 years. Millions of models, meaning a lot of storage you need. Each model at least is 4 to 5 gigabytes of needs storage. So that's first. Now, me as an engineer, I would like to build an app on one of these beautiful open source models. Or I would like to fine tune and enhance a model that creates another model. And then I will take this model and I will copy it on the quantity of GPUs I need to serve my user. Let's say I want to build a mobile app that does stable diffusion. It's a new model that it has beautiful photos. For every 1,000 users I have, I need a new GPU. And then I'll have to scale these GPUs. So one model of this 300,000 model, like ChatGPT, have 100 million users, just one model. Right. So imagine how many model will be and how many model will have 1 million of users. And each one of these users I need to scale by GPU. So there will never be enough, based on the current computation landscape, based on the current architecture of how models are built, if we just keep going that way, there will never be enough GPUs to match the demand. So then comes the cost. So just like the EVM, as Kai showed, it comes in a funnel. Who pays more gets the transaction happening. Gets his transaction done, meaning get his inference done or deploy his model. And that's what's happening right now. So the prices for the GPUs are just going skyrocketing because those who can pay for 100, 1,000, 2,000 GPUs are very well funded startups. Just like OpenAI, $700,000 a day. Netflix, $20 million a day. It's crazy. Now, yeah. Yes.
Got it. So we've got this set up here. There's a huge amount of demand for these GPUs, and the solution here is aggregating consumer GPUs in the way that you have, right? Using token incentives in order to onboard a distributed cohort of individual contributors to become part of this network, and then allowing people to tap into these things, right? And specifically in your case for rendering workloads, Ahmad, in your case for machine learning workloads. Tell me a little bit about how the two of you were working together, right? Because Render announced something called an open clients framework recently, and that's sort of kind of been the beta for this partnership. But tell us a little bit about what that involves.
Sure. So it's really a watershed moment for the Render network. As I said to date, we've been very focused on render jobs. We've been bringing other third-party renderers to the network, but it's been all rendering. And as this AI opportunity has emerged, our community has spoken. And IONET proposed a great proposal to essentially turn the Render network into a platform with open clients. And so to expand beyond just running render jobs, but being able to run multiple B2B clients on the rendering side and the AI side. And it makes a lot of sense when you think about it. Otoy is phenomenal at the artist workflow. It does a great job simplifying the end-to-end and delivering a phenomenal solution. What we're really looking for the Render network is to find the Otoys for AI, beyond, with the real skill set, with the workflows and the orchestration to really tap in to the Render network and drive AI compute volume on the network. And we're really excited to have IONET as our first partner.
Yeah, let me tell you a story how it all started. So back in April, when I met a friend in SF, he was the founder of Stable Diffusion model, really famous. He told me we were building a $60 million data center that has RTX 4090. It's a GPU model. And they already built it, and they need another 40,000 of them. So I was like, well, yeah, I'm building this deep end that we're thinking to have 2,000, 3,000, 4,000 GPUs, and I'm so happy about it. And it's like, I want 40,000 GPU, just me. And it's like, okay, let me take a step back, and actually, if I could serve him, that's a lot of millions of dollars a day. So where can I get 40,000 GPUs? And also for RTX 4090. So. And she should have good internet connectivity, certain types of security, certain locations, and so on. There's no one but Render. So we submitted the RMP 004 regarding open us your API, let us bring our distributed computing framework and networking architecture, install it on your GPUs in a way that is capable of serving such large startup. And because our protocol is built on Ray, and Ray is actually the library that is currently being used by OpenAI to distribute ChatGPT model over 20,000 GPU. They used it to distribute over 300,000 CPU and 20,000 GPU when they trained the model. And Ant Group, for example, is using this to distribute training on 500,000 GPU every day for their finance department. Same for Instacart, same for Uber. So we're built on top of a library called Ray, and this, we basically forked Ray a few months ago, and from there we took it to a decentralized direction, because this helps us not just rent 1 or 2 GPUs, because these enterprises, they don't want 1 or 2 or 32 GPU or 64 GPU. They want 20,000 GPU, 40,000 GPU. And this quantity of GPUs requires distributed computing frameworks that allows you to schedule tasks, handle fault tolerance, and so on. And this is why no one yet in the market have managed actually to serve a real use case in AI yet. Because if you want to serve amateurs, sure, give 32 GPU, give 64 GPUs, that's the maximum you could do. But once you want to start serving startups and big companies, enterprises, you need to talk about thousands of GPUs. You need a very solid fault tolerance, task scheduling, networking architecture, something beyond. Render has the supply, we have the technology. We put it on top of that, then we basically, all the supply and render could act like a hive, all of them like one mine, even though they're distributed across the planet.
Got it. So would you describe that as sort of this batching orchestration layer, right? Like taking a job that would normally happen in a data center or like on an enterprise grade A100, H100 card with, super fast interconnects or a decent amount of RAM. How do you split that job up between 50 consumer cards that are distributed across the world, right? Like that's a core distributed systems computer science problem.
Yeah.
And there's a lot of resources that have gone into solving that problem. One of which is Ray, and there's a handful of other frameworks that you use to kind of achieve that scale of parallelism on the consumer GPUs. But like you mentioned, there hasn't been an aggregation of consumer GPUs in the way that is possible with render, right? We haven't seen that many consumer cards hooked up to a single sort of infrastructure up until now. And so I think it's a really interesting experiment. Do you want to kind of talk through where things are built?
Yeah, of course. Let's play the video.
Yeah.
So this is a zoomed video, just a kind of mobile view. So we have the IONET Cloud, the Worker, and the Explorer. Currently, we're just going to talk about the cloud barely there's enough time. Here you can see live market prices of the current GPUs available in the network. It's just a test net. You can see that I have, I think, 40 RTX A6000. So right now I'm going to make a cluster on these distributed GPUs. As you can see, I have Kubernetes clusters or I have Ray clusters. So Kubernetes opens massive use case. Imagine decentralized Kubernetes. Here I'm going to call it Multicoin Summit 20. Next, I will choose the supplier, where the GPUs are going to come from. Are they coming from Render Network, from the IO network? And each type of these GPUs are either storage optimized or lightweight computing optimized and so on. Now I could select one location from where the GPUs could come or multiple locations. And the internal architecture of the network will stitch these GPUs together. Next would be selecting the GPU type or CPU or even a TPU. And then I'll choose the security compliance because that's something really important. After that, I'll choose the connectivity tier of this. And the more, if you want the highest speed, I would just go with the highest speed. Then the cluster purpose, I could go from PyTorch, Ray, Ludwig, IO native app, and even Unreal Engine streaming and so on. Right now, we're going to go with Ray. And then next, I will select the quantity of GPUs I need to take. And after that, I will, and basically...
So, Ahmed, what exactly is happening here? This is an engineer that's deploying a cluster.
I'm making a cluster right now of GPUs that are from all around the world. I'm going to, now you'll see next, that with these GPUs, they're all going to come, they will act like a single cluster. So let's just wait for a second. Here's just I did the mistake here. Anyway, so what happens right now is cluster is being deployed. This is sent to the network, like someone wants to deploy a cluster. And what's happening right now that I rented the cluster for an hour. The network goes, it brings the GPUs from the render network. It installs on them, or it's already pre-installed, all the drivers that run this machine learning workload. And now I have my cluster. I could extend rental, I could have it for longer time. And you can see the cluster has an ID because it's on chain. And then I could see that the cluster is still going to deploy. So right now I'm going to just scroll down and see more information about the cluster. About, for example, I can see I have a Ray dashboard link, Visual Studio Code, Jupyter Notebook. I could have an experience just like any cloud. Here you can see all the nodes that are part of this compute cluster. And each node has an ID, which you could go to the Explorer and see. Now, each node, as you can see, how much it's going to pay, how much is slashed, and so on. I'm going to just go scroll so much down now and just choose a node randomly. And once I click on this node, you'll see that I'm going to the Explorer page of this node, looking at, this is the public view of this node that anyone in the world can see, that this node currently is hired, this is the uptime, this is how long it's been up. I can see the score of this node, what type of encryption it has, whether it even could have verifiable SOC 2. Now I'm going back to my clusters. Already was deployed. All these GPUs from across the globe, now they are this is real. I just recorded it a few minutes ago. Now I'm going to go to the Ray dashboard. You'll see all my GPUs in the network. All of them just got stitched together. And what I'm going to do next is I'm going to show you that there's also Visual Studio Code. I just need a password. I go inside it. I can code and have an experience just like any cloud platform. The UX is really critical in the crypto market. We don't have a good UX. And here, I don't want to add one more solidity to the world. We have to make it simple for the engineers to really adopt this new technology. Now, next, I'm going to show you, like, this is a playground on top of this cluster where you can kind of train a small model and fine-tune it. So you'll see the neurons in the network. And later on, you'll be able also to see the millisecond of latency between the nodes communicating together and so on. But here we're talking about neurons of a small neural layer, like this kind of a model that is basically trying to predict an image. And this is just, of course, kind of an example of a running cluster. And you can run a lot of workloads in this cluster, just like any compute cluster. So the experience is just like any cloud. Latency is amazing. There's a lot of customization that you could do here. I think that's it. I think the video's done. Sorry.
Nice. Mic drop.
Took us a while.
So
Thank you.
just for the folks who might have tuned out there, what Emma just described was a distributed cloud offering that kind of operates at parity with a centralized provider. You can basically do anything that you would do on sort of like an instantiation, like spinning up a cluster on an AWS or a GCP instance, but theoretically at a fraction of the cost. Now, we haven't, talk to me a little bit about pricing and how you think about that, but
allow me a second. So you saw the cluster right now was like 40 GPUs. If we have the supply, we can have more than 50, 60, 70,000 GPU in 10 seconds. All of them, they will be in the cluster, and you will be working, even though they're all across the planet. This is something not even seen in any cloud provider at the current moment. About cost?
Got it. Cool.
Sorry.
Yeah. I mean, that's, And so you've set up the environment, right? Someone can go in and distribute a workload in the way that they normally would, and you handle all of the messiness around kind of orchestrating it and dealing with input and output and latency and bandwidth around communication between each of these nodes. The question becomes, who is going to do that? Like, who is the ideal customer, and what is the kind of workload that they end up doing? Are they running inference workloads? Are they running training workloads? Are they running more rendering workloads? Like, Trevor, how do you see sort of demand in the market in general shaping up? And how does the network, like Render specifically as a general purpose platform now, taking on a bunch of different workloads, how do you think about serving that aspect of the demand?
So lots there. I think what's really interesting in that demo is we actually gave a small sample of 20 or so render nodes to just test the software running on the nodes successfully on the actual nodes that we use. And so this was a really key milestone for me, so really exciting to see that because it's really a first step into this. Where we see the demand, well, I can talk for the rendering side, and I think you're probably better suited to talk for the AI side. But on the rendering side, there's a lot happening. We've been working on adding multiple renderers. When you look at what AI has done to the 3D graphics space with companies like Runway and more, you're seeing a disruption in the tools and how people create motion graphics. It's completely simplified it. And for us, we really believe that will be the key to onboard the next generation of Photoshop or user-generated content users to rendering is through these types of tools. So very excited there. As I said before, the step towards spatial is critical, and that's a 100x jump in compute. When we look out a little further, we believe we'll be at a point where you don't need the glasses within the next 5 years. So things like light field displays, and those are 1,000x the compute. So a lot more coming down that pipeline. And then finally, I see all of this really converging. We already use AI in the render process to denoise and reduce the process. And I'm seeing more and more of it come together as we drive towards real time. And I don't believe real time can be achieved without a combination of the two. And real time is, again, another massive step up in compute. So it's really exciting as we look at the combination of these on the render network, driving volume and value to the participants.
Yes. So when we started the IONET, we wanted it to be, especially the IONET Cloud and the IONET tech stack in general, to be general compute or general ML, end-to-end machine learning workload serving and inference training from the dataset aggregation to the point where you actually inference the model. But through the testing and through all the different startups and ML engineers we've been working around with, the Race Summit we've been in a few weeks ago doing to OpenAI and Uber and Instacart, all these guys, we're noticing the whole industry is shifting investment toward model inference specifically more than model training. Because there are these supercomputers, the wafer scale engine, a new GPU that's like this huge, just the chip, the silicon chip, and they are really huge and fast and so on. So if you look at the lifetime or the life cycle of a model, the training is so small compared to the whole life of the model. Training is 10% of the lifetime of the model, and then you have 90% of this life is actually inferencing the model to users and trying to make money out of it. So most of the network can handle both training until inference, but we're noticing inference is so critical. And what makes so we were like even us putting more investment into model inference, model tokenization, deploying models on a lot of GPUs, and then people are able to inference models distributed, what they call tensor parallelism. So yeah, inference. That's more where's the money for the long term. Like more sustainable income for a project is in inference.
Got it. Super helpful. So maybe sort of stepping back and looking at the general architecture that we have in place here today. The fact is that this business is uniquely enabled by crypto, both of the things that you're working on. Render in particular as an aggregator for GPUs, yep. And IONET is this sort of orchestration layer, kind of facilitating workloads between them. The fact that you can give token incentives to bootstrap massive supply-side infrastructure, it's been a very powerful primitive that a lot of kind of teams in the space over the last 4 or 5 years have been experimenting with. Quick plug, I'll be on stage in 2 hours again talking about this in a little more detail. But there's a specific blockchain primitive that's needed for that, right? And Trevor, could you talk a little bit about the decision over the course of the past year or so to migrate the system to Solana, given your expectations around throughput, latency, payments, and same for you, Ahmad. You've deployed whatever infrastructure exists on chain on Solana. Could you tell us a little bit about what went into that decision and how you went around that?
Sure. Well, it was a big decision, definitely one that was debated in the community. What we were looking for was an L1, one that had a low, stable cost, one that had a proven history in deep-in, and then one that could handle throughput at the scale we believe is coming through. And what really excited me about our choice in Solana is, a big part of our vision has been not just incentives, but really using the blockchain more and more. We're in the age of AI at the moment, and what that means is you have lawsuits about using your data to train and tracking and provenance. And what's really exciting for us is I see a path towards putting more and more of the creation on chain, using compressed NFTs, being able to show you created it, being able to show proof of ownership, being able to show royalty streams. And I don't believe any of that could have been possible without this change. So for us, it's a really exciting move.
Yeah, for us, I think you have a model, and there's millions of models, and then one model, you need to tokenize it, and then, because if you want to inference the model, you have to use the token of this model to inference the model. So, and I would use like 1 million token or 1,000 token to get a book of results. Now, we needed a chain that I could basically do all this microtransaction. When people inference one of these hundreds of models, they will have to tie the inference with a microtransaction so they could get the result out of the model. So that's millions of transactions. And because Solana has the fire dancer coming in and all the upgrades on the network, they're the only one that actually could be economically possible, because you need, like, each inference should cost 0.001 cent and such that. There's just Solana.
Exactly.
All right, guys. I could sit and talk to you guys for another hour, but we're at time, so appreciate you helping.
Thank you.
Thank you.
Sure.